Out of the multiple operations that can be performed on sets, we will discuss today the most important operations on set. One of the most important are the union and intersection of sets. Union of and intersection of sets are basically hold a very important place in operation of sets. So we are starting from the from these two operations, and then we will move towards the remaining operations of set. First of all, we have the union of sets, and the other is intersection of sets. Intersection of sets. So let's discuss them one by one with their definition, notation, and examples. Union of sets. Start from union of sets. A very easy concept but important. Important to understand properly. We'll start from its definition. Union of sets is basically stated as it is a set consisting of all the elements which are in set A, which are in set A or set B or in both. Okay, this is how the union of set is defined and stated. Okay, let's see how we can define it mathematically. Its mathematical definition is how it can be presented mathematically. If we define the union of sets in terms of set builder notation, it is also defined as A union B is equals to X such that X belongs to A or X belongs to B. So this is how the union of sets can be represented in terms of set builder notation. Okay, this is the set builder notation. This expression can be read as A union B is equals to set of all x such that x belongs to A and x belongs to B. It means that the elements that comes out after finding the A union B will belong to A as well as belong to B. But keep in mind that there should be no repetition of the element that exists in A and B. If there is an element that exists in A as well as in B, we will take that element once. Okay. Now let's see how we can represent the union of sets in terms of by using the Venn diagrams. We'll see the Venn diagram representation of A union B. Now let's see how we can represent the A union B in terms of Venn diagram. Let's have an example to represent A union B. For example, we have A is equals to 1, 2, 3 and B is equals to 3, 4 and 5. Now how you can find their union as A union B is equals to 1, 2, 3 union 3, 4, 5 and the answer will be 1, 2, 3. As there are 3 in set A as well as in B, we will take it once, then 4 and 5. So in A union B, we have considered all the elements of A and B by keeping the redundant element as 1. Okay, this comes out A union B. Now let's see how we can draw its Venn diagram. If we have A this and B is this, and we will find their union, then what we will have? We will have a Venn diagram like this. Why I have made this overlapping section? Because we have a one element in common, that is 3. This element is common in both A and B. So while drawing the Venn diagrams, there must be a overlapping section. So this is A and this is B. We write here 1 and 2 here, and 4 and 5 here, and the common section is 3. And A union, and I'll represent the A union B by drawing the lines, that which portion represent A union B. So this lining portion represents the A union B, that you are considering all the elements of A and B. So this is how we can represent A union B in terms of Venn diagram. So this is the Venn diagram of A union B, in which we are considering all the elements of both the sets. Okay, this is the A union B. Now let's have few mathematical examples to see how you can find A union B. Example: if you have one set, A is equals to 2, 3, 4, 5, and B is equals to 2, 3, 5, 7, and 8. Now you will be asked to find out A union B. How you will find it? You will find it as A union B is equals to 2, 3, 4, 5 union 2, 3, 5, 7, 8. Okay. Now we will write how: 2, 3, 4, 5. Now since 2, 3 and 5 are repeated in the set B also, so we will skip them and we will choose the other elements that are not in A, that is 7 and 8. So A union B comes out 2, 3, 4, 5, 7, 8. Okay. Keep one thing in mind: there should be no repetition. There should be no repetition of element. Repetition of element. As it is also, as it besides it is not satisfy, it will not satisfy A union B, it will also not satisfy the condition for a set, that for a set there should not be, there must not be any element that is in repetition form. Okay, so now we have some few facts about the A union B that you need to keep in your mind, or that are very important to consider. Okay. One fact is, union of any set with empty set. We have already discussed the concept of empty set. A set that has 0 number of elements is an empty set. Okay. Union of any set with empty set is the set itself. For example, you have a set A is equals to 1, 2, 3, and B is equals to empty set. What will be A union B? A union B will be 1, 2, 3. So it is satisfying the condition of A union B is equals to A union phi is equals to A. It means you will take all the elements of A as there are no element in the set B, that is an empty set. Okay. One more thing that you need to consider here is important point is union of two sets is commutative. This is the property of union of two sets. What is commutative? Commutative means A union B is equals to B union A. It means the order doesn't matter. Whether you find the union by keeping A first and B in the second position, and or you keep B first and A in the second position, the answer will be the same. Let's see how. Let's have a proof through example. Let's say A is equals to A, B, C, D, and B is equals to C, D, E, F. Okay, so how you can find out the two? How you can find out this proof? First, we will find A union B, A, B, C, D union, in which we have kept A at the first place and then B, C, D, E, F. A union B will be A, B, C, D, E, and F. Okay, now we will find B union A. B union A is, now we will place C, D, E, F here, union A, B, C, and D. And what will be B union A? We'll write all the elements C, D, E, F, and we'll check which element is not the part of which element is not the part of B in A. What left is A is left, B is left, C and D has already taken. Now we have to see that we have to compare the equation 1 and equation 2, whether they are equal or not. Now you can say that this is left hand side of the equation and this is the right hand side of the equation. Now match the elements. Since in A union B there is A, in B union A there is A, then in B, B, C, D, all the elements are matching. It means that A union B is equals to B union A, hence proved through, since left hand side is equals to right hand side. So this is how we have proved the property, the commutative property of the two sets. Now we will see that how intersection of two sets differ from union of two sets. Section of two sets. Let's see how it is defined and stated as, this is the another set of operations besides union of two sets. It is defined as set consisting of all the common elements of A and B, of set A and B. So this is how it is stated that when while finding the intersection of two sets, the result will be all the common elements in both the sets A and B. Let's see how you can define it mathematically. Its mathematical notation is represented as A intersection B. It will be read as A intersection B. Now let's see how we can write it in set builder form. In set builder form, you can write the intersection of two sets as A intersection B is equals to X such that X belongs to A and X belongs to B. Now let's see how you can read it as. You can read it as set of all X such that X belongs to A and X belongs to B. It means X must belong to both A and B. There is a relationship of and between the elements of A and B. That if an element is in A, it must be in B also. So this is how we represent the A intersection. The important difference between the intersection of two sets and the union is this symbol. In union, we have seen that this symbol was replaced by or. There was an operation of or, but in intersection there is an operation of and. That means you must satisfy both the conditions. That is that element must belongs if the element belongs to A, it must also belongs to the B. So this is how we define intersection of two sets in mathematically. Let's have few examples. One of the example is A is equals to red, blue, green, okay, and B is equals to blue, white, yellow. Okay, these are the two sets A and B. Let's see how you can find their intersection. A intersection B is equals to, first we will write the sets red, blue, green, intersection blue, white and yellow. Okay, these are the elements and their intersection will be, which element is common in both of them? Only the element blue is common in both of them, so we will write blue here. So this was the only element that was common in both the sets, so this is A intersection B. Now how you will represent A intersection B on Venn diagram? Let's see the Venn diagram representation through this example. Venn diagram representation. We will draw the diagrams first. We have a set A consisting of red. We have a set A and set B. We'll write their elements as, in set A we have red, blue and green, and in set B we have blue, white and yellow. What will be their intersection? It will be like this. It will be overlapping or not? Yes, it will be overlapping because we have one element in common. Okay, then we will write their elements as red and green here and white and yellow here, and the common element was blue. Now I'll highlight the portion that represent the A intersection B. So this is the portion that represents A intersection B. So this is the Venn diagram of A intersection B, how you can represent in the form of Venn diagrams. Let's have few more examples. Example 2. We have A is equals to 1, 2, 3 and B is equals to 1, 2, 4 and 5. Their intersection will be A intersection B is equals to, what are the common elements? I'll encircle the common elements or I will draw it like this. Common elements are this one, okay, this one and that's it. So these are the common elements of A and B, and we have evaluated the A intersection B as this. So this is the A intersection B. Okay. One more example. Example 3, in which we have A is equals to 1, 2, 3 and B is equals to 5. That is an empty set. We have already studied about the empty set. It is a set consisting of consisting of zero number of elements. So there is no element in B. You can also say that. Okay. What will be its intersection? A intersection B is equals to, now just check what are the common elements in both the sets. There is no common element. As in A, there are 3 elements, and B, there is no element. How you can find the common elements? There is no common element, so the output will be an empty set. Okay, so from here we have got the fact that whenever you find the intersection of any set with an empty set, it will be empty set. Okay, let's have few facts about A intersection B. Facts of A intersection B. We'll start from A intersection B is subset of A and B. It means when you find A intersection B, then the elements that will come in A intersection B will be the subset of A as well as B. Okay, this is the fact. You can also prove it by means of an example. Okay, another fact is A intersection B is commutative. Now, how commutative? As we have already studied in A union B, that A intersection B is equals to B intersection A. That means order doesn't matter, whether you find the intersection by keeping the set A first and then the set B, or keeping or vice versa. So the order doesn't matter in finding the intersection. Next is, if you find intersection with any empty set, then the answer will always be empty. That means intersection of any set with empty set is always empty. Always empty. So these are the few facts about A intersection B, and you can also prove them through examples, as we have given the proof of A union B, the commutative property of as we have already given the proof of commutative property of A union B. Here we have also studied the same fact. You just need to clarify your concept by taking the examples and prove their right hand side and the left hand side. So hope so these the A union B and A intersection B concept will be clear from today, and stay tuned for the more operations on sets, like difference of two sets, complement of a set, universal and complement of a set, in our next lecture. Thank you.